Okay, class, we're going to be looking at areas of trapezoids, rhombuses, and kites. Okay, you can go ahead and fill these out on your spreadsheets that I gave you yesterday after we get through this video if you want to transfer the areas of trapezoid over to that spreadsheet along with the area of a rhombus or kite. Rhombus and kite have the same formula. For a trapezoid, you take 1/2 times the sum of the two bases. And for a rhombus or kite, you take 1/2 times the diagonals. So you have diagonal goes from vertice to vertice, so you multiply each of those two diagonals and divide it by 2. So let's look at a few of these and work some of these formulas. Example 1 says a car window is shaped like a trapezoid as shown. Find the area of the window. So we're going to use our formula, area equals 1/2 times the sum of the bases. Oh, I'm missing something in this formula, guys. I'm so sorry. This needs to be height. You need to put in a height there. So it's actually 1/2 times height times the sum of the bases. I apologize. I left that off the formula. So back up here in your notes, you want to put in it's actually 1/2 times height times base 1 plus base 2. So I do apologize. I left off that H. Okay, so then we're going to fill in our formula here. We have area equals 1/2, and then our base one is, it doesn't matter which one we use, we'll use 20 plus the other base, which is 36, times our height, which is 18. So then when we multiply all of that together, we get 1/2 times 18 times, and we'll go ahead and sum the 20 plus 36, we get 56. If you have your calculators, you can go ahead and put that in your calculator. 1/2 is just 0.5 times 18 times 56. That gives us area equals 504 inches and then squared because it's area. So that's how you do the first example. Now the second example won't be quite as easy because we're not given everything that we need. So on example 3, we still want area equals 1/2 times the height times the sum of the bases. But here we don't exactly know what height is on here. We have to find out what the height is. So this right here would be what we'd want our height to be. But what we can do, it's the same height as if I were to draw this altitude right in here, creating a right triangle. So what happens is we can use this right triangle information to find this missing height. We know that this very bottom base is 16 and we know the top one is 11. The difference should give us this little segment right here. This little segment right here is 5 because that's the difference in 11 and 16. So then we have a right triangle where we're missing one side. That's where we can use the Pythagorean theorem. So we get a squared, 5 is your leg. 5 squared plus b squared is the height equals c squared, which is your hypotenuse of 13. So then we get 25 plus b squared equals 13 squared, which is, by the way, 169. And then we subtract 25 from both sides. We're going to get b squared equals 144. But then we take the square root of both sides. We get b equals 12, which is also our height. So this right here is actually 12. So now we can plug into our formula up here. We get area equals 1/2 times your height, which is 12. The sum of the bases, we get 16 plus 11. So we get area equals 1/2 times 12 times 27. When we plug that into our calculator, we should get 162. So the area is 162 feet squared. So the tricky part about that was going ahead and finding that height. So that's trapezoids. We're going to flip our notes over. We're going to find the area of this kite. For a kite, the area is 1/2 times diagonal 1 times diagonal 2. So we have to find the lengths of each diagonal. It's the trick on these. We have 1/2. Our first diagonal, this one is kind of given to us. This diagonal is 6 because each one of these little parts is 3. So it's times 6. The other diagonal you take 4 plus 1 and that gives you 5. So you have 1/2 times 6 times 5 gives you 15 centimeters squared is the area of that kite. So that's how we find the area of a kite. The next one we're going to look at is the area of a rhombus. We're going to have to go back and remember properties of rhombuses. Still the same formula as a kite, which is 1/2 times diagonal 1 times diagonal 2. And on this one you can see that we already know one of the diagonals is 24, but we don't know the other diagonal. This is where remembering your properties of rhombuses comes in handy because the diagonals create a right triangle or a right angle when they intersect. So you will have a right triangle formed. So you know, let's just look at ST and then the center as that triangle. We know that also, since it's a parallelogram, the diagonals bisect each other. So since RT is 24, we know half of that is 12. We know the hypotenuse is 13. We need to find the third side. So again, we can use the Pythagorean theorem. So we do a squared plus b squared equals c squared. Your a is 12, which is a leg, so you get 12 squared plus b squared equals your hypotenuse squared. That gives us 144 plus b squared equals 169. Subtract 144 from both sides. And you get b squared equals 25. So when you take the square root of that, you get b equals 5. So we know that each part of this is 5. So we know that the other diagonal now is 10. So our two diagonals are 24 and 10. So we do 1/2 times 24 times 10. So the area is 120 feet squared. And that is how you find the area of a rhombus. So you now know how to find the areas of trapezoids, rhombuses, and kites. Thank you for listening.